is session 4A, Reliability and Readiness for Aircraft Systems. Our first speaker will be virtual this morning. Mr. Jerome Perkins is the Operations Manager at AFOTEC, Air Force Operational Test and Evaluation Center, Detachment 5 at Edwards Air Force Base. He will be speaking about using the logistics composite model and Bayesian statistics to evaluate the B-21. So Jerome, over to you, and I will give you a 5-minute warning in the chat if you can see it, but otherwise keep your eye at 10:25.
Good morning. I'm going to discuss the use of logistic composite modeling and Bayesian techniques to address the B-52 and the B-21's evaluation of availability for operational tests. The slide you see before you is the overview of what we're going to discuss today. We had a problem that we needed to solve, which was answering the availability solutions, a brief discussion about LCOM and the history, how we're going to implementation of this and the results to date, and some lessons learned and what our path forward. So our problem statement was that the B-52 and the B-21 team needed a tool to evaluate material availability, which is a key performance parameter outlined in the CDD. Because of the CDD required a defined fleet size and a test duration that could not be provided in the timeframe required to support IOT&E and also to support acquisition decisions. We deal with a potential of small data sets for failures and repair data, the short test duration, and the systems that are very complex. The outcome of this is to ensure weapon system reliability and readiness through comprehensive testing and evaluation, which is critical. The solution was to use the logistic composite model analysis toolkit, which is an Air Force model that is used for a lot of different programs. The approach was to update the platforms inside of the model, which the inputs include the failure rates and the repair times. This approach would allow us to use all the data captured during developmental tests, as well as operational tests and any real-world data that's provided. This also supports small sample size and short test duration. A little information about the logistic composite model. It employs resource queuing, stochastic process, and Monte Carlo methods. It models reliability, maintainability, support infrastructure, and operational ConOps. The measures that are impacted are the availability, sorted generation rate, and lifecycle costs. The LCOM model is managed by the Air Force Lifecycle Management Center, EZJS, at Wright-Patterson Air Force Base. I did include a phone number and an email address if anybody needs to contact them to get a copy of the LCOM ATK. The LCOM pedigree dates back to 1960. It was used primarily to validate manpower and also to look at various KPP analysis. LCOM has been used on numerous studies to include JSF, F-22, KC-46, MQ-9, B-2. We also have used it here on a lot of different programs to include Global Hawk. The model has also been used by other services, Army, Navy, Marine Corps, as well as partners for JSF. The plan to implement LCOM modeling and Bayesian approach, we leverage data from all phases, as we discussed earlier, to feed the model inputs. As you can see over to the left where my arrow is pointing, We take in flight test data as well as IOT and DT. And we would go to a joint reliability maintainability evaluation team to adjudicate failures. At that point, we will also use Bayesian to do calculations based on the prior inputs. Based on the prior inputs, which was provided by the contractor, which are the estimates that went in as the baseline of the model. So as we get the failure data or repair time data, we use a conjugate prior, which is the gamma distribution, to produce a posterior distribution used to update the model failure rates and repair time. Currently, we're working on a tool to automate that, because in most cases, like the B-21, you have the whole platform, which could exceed 10,000 components. So manually updating those would be very arduous. And then at the end, you would get a compare model, produces ranges of outcomes using Monte Carlo, basically addressing the probability of meeting your A sub O requirement, which would be your availability. To date, we have used LCOM to evaluate the deployment footprint impacts, determine sparing, facility utilization, manpower utilization, schedule maintenance impacts, MILCOM priorities, so that we can provide the user with the impact of prioritizing which buildings need to be built first to support ops, flying schedule effectiveness, basically taking a wartime sortie flying schedule and say how effective we are in meeting that sortie generation requirement. And then availability estimates to support early decisions. Bayesian, we're currently beta testing a Python tool, which we discussed earlier, with JARMAT data. We're coordinating those results with the program office and the prime contractors, which would be Northrop and Boeing. And we plan to have the Python tool live by July of this year for failure rates, and then by January of 2026 for repair time updates. Oh, I forgot to bring this up. If you have any questions, please ask it at any time, and I'll be glad to address those. Some of the lessons learned we have learned from going through this process is that a lot of our contractor estimates for failure rate and repair time lack alpha and beta data, which means they don't have the distribution for their failure rates. For example, MTBF, basically they just have the average, but no probability of meeting that requirement or a distribution of that requirement. So we had to select a conjugate prior that matches our data distribution. So in this case, the failure rate is a exponential failure rate, and the repair time is a log normal failure rate. So we decided to use a gamma distribution for that. Also, you have to decide how you're going to update your component failure rate and repair time. Most of the component data is either by logistics control number or work unit codes, or we can update by part number. The example would be if you have two engines, a right engine and a left engine. If you do it by LCN, it would be by location. That'd be the right engine and the left engine. If you do it by part number, you will update the reliability and update both left and right engine that way. So you have to make that decision up front to use the tool. But We are putting an administrative function so that you can make a decision down the road if you wanted to change and just update the component reliability, or down the road you want to update both. What that will give you is if you had failures associated with a location, the model will address that, and then when you run it, you'll get the actual distribution correctly for each component. Our current path forward is to complete the tool and provide that to EasyJS, and they will be the keeper of the tool going forward and providing all the updates going forward. And we're documenting all our assumptions and processes. And as I said, we would share the tool with other programs who use LCOM or other RMNA modeling and simulation tools. This is just some information we pulled together where we use to understand Bayesian or pick up techniques to apply to the process of using Bayesian with LCOM. This is just some information for you that you can look up that could help you with Bayesian techniques. Any questions?
I have one question for you. Roughly
Okay.
how long does it take for the model to run?
Hold on, we couldn't quite hear you.
How about now? Can you hear me?
Try it again.
Can
Yeah, I can hear you now.
Okay. How long does it take the model to run?
It keeps cutting out on me.
How long does it take the model to run?
It depends on the complexity of the run. For us, our B21 model is probably one of the largest models we ever had. Some of the runs take hours, and some runs depends on the complexity of the run, could take, we'll be ready by the next morning. But in most cases, with adequate resources, we're running in a virtual environment. So we're running 4 cores with about, I think, 32 gigs of memory. We can get done in 2 to 4 hours.
Okay. Are there any questions from the room? And I'll go back and see if there are any questions. I don't see any questions online, so let's thank our speaker.
Okay, thank you.